Hello, so today we're going to look at how you measure density. The density is equal to the mass divided by the volume. It tells us the amount of particles in a certain space. So if you think of a dense wood, the trees are really close together. So we're going to find the density of a regular shaped object, like this, and an irregular shaped object, like this stone. So you can actually try this if you can get a big stone that you can try it with. So we've got to find the mass and the volume. Well, finding the mass is quite easy because all we do is put it onto an electric balance, like this one. So the mass of that one, I hope you can see it, is 175.9 grams. Then we need to find the volume. How do you find the volume of a shape like this? I hope you remember from your maths. It's the length. Well, the length of this object is 4 centimetres times the width. Well, the width of this object is 3 centimetres, and then times the length, which is 5 centimetres. So the volume of this object is 3 times 4 times 5, which is 60 centimetres cubed. So we need the mass, 175.9 divided by 60. Can you do that on a calculator to find the density of this object in grams per centimetre cubed?
So if we look at our equation, we have density equals mass divided by volume. So we need to look back at the numbers that we had for these and put them into the equation. The mass was 175.9 grams and the volume was 60 centimetres cubed. So on your calculators, 175.9 divided by 60 gives us 2.9 grams per centimetre cubed. The density of the block was 2.9 grams per centimetre cubed.
So the second object we have is a stone. Now this one is a little bit more difficult. Finding the mass is quite straightforward. We just put it on the electric balance again, and it's 61.7 grams. The volume is a bit harder, so we have to use one of these cans. This is called a displacement can or a Eureka can. And it works on the principle that when you get into the bath, the amount that the water will overflow is equal to your volume. So it's got a spout, and we fill the water right up to that point. This time, what I'll do is I'll let it go a little bit over. So fill it up just a bit too much, and let any of the excess water come out. And we wait until that has completely stopped dripping before we can start our experiment. So while we're waiting for that, what we're going to do with our stone is take the stone and place it very gently into our Eureka can. The water will overflow by the same volume as the volume of that stone. And by capturing that in a measuring cylinder, we can then actually find out how much volume that stone. So let's lower the stone into the displacement can, Eureka can, and measure the volume. Let's put it in very carefully. You can see the water coming out. We'll just wait until the last drip of it, just a few more drips coming out. And then once it's stopped, we'll have a look at the measuring cylinder and see the volume.
So here's our measuring cylinder. If you look closely, the value is 25.5 centimetres cubed. So again, we use our equation, density equals mass divided by volume, and we put our numbers in. The numbers were 61.7 grams and 25.5 centimetres cubed. So on your calculator, 61.7 divided by 25.5. And we can see that the density of the stone was 2.4 grams per centimetre cubed. So here's another experiment to find the density of water. We put a measuring cylinder on an electric balance and re-zero the balance. So now it's reading 0, and we pour in exactly 50 centimetres cubed of water. So it's only measuring the mass of the water. So we pour it carefully into the measuring cylinder to get 50 centimetres cubed. Looking closer at the measuring cylinder to check, you can see it's exactly 50 centimetres cubed and 50 grams on the scales. So using the equation density equals mass divided by volume, we need to put these numbers in the right places. So the mass was 50 grams and the volume was 50 centimetres cubed. So we do 50 grams divided by 50 centimetres cubed, and I think we can work out that that is 1 gram per centimetre cubed. The density of water is 1 gram per centimetre cubed.